Hello everyone. We are going today to talk about how to calculate a moment. In problems involving free body diagrams, often the equation involving moments is needed in order to solve the problem. So what is a moment? Well, moment is essentially a force that is acting around a point, creating some kind of a torque. And that is what we call the moment. Okay? Now, what is important here is to remember that the moment is calculated about a point, which means that the distance d between the force and the fulcrum is very important. This is what gives us the moment. So m here, I wrote it as a cursive capital M, represents the moment. F in this case represents my force, and D would represent my distance. So usually a force is measured in newtons, a distance is in meters, so the moment will be in Newton meters. Could it be measured in pounds and in inches? Absolutely. If you deal with the little VEX motors, for example, and if you look at their properties, you will find out that the moment or torque provided by those motors is given not in Newton meters, but in pounds and inches. Okay? So, how do we calculate this? Well, let me show you two little examples here. Okay? So what is the issue right here? Well, we have a fulcrum, we have a point A, which allows us right away to write that what we're looking for will be the moment around the point A. We have a force F acting on a bar right here. And we're going to say that this here is essentially just welded together. Okay? We have the distance D between the point A and the place where the force F is acting upon this bar. In this case, it's going to be very simple. We just use the formula. It's going to be the force F times the distance D. Okay? Now, one more thing we need to consider when we deal with moment is the direction in which the force will make everything turn, either clockwise or counterclockwise. And you can associate a positive and a negative sign to those if you want, but by convention, when we go counterclockwise, we're going to associate a positive sign to the moment, and we are going to associate a negative sign to the moment when we go in a clockwise direction. So this obviously goes into the clockwise direction, so this moment will have a negative value. Okay? Now if you look at the second problem, you will see something slightly different right here. You will see that the vector F is not perpendicular to this bar. It is at an angle alpha. So what you want to do here when you calculate the moment, you want to consider that the force F has to be perpendicular to this bar in order for the moment to be calculated correctly. So what you can do here is you can split this vector F into its horizontal component and its vertical component. So the vertical component will be this one, and the horizontal component will be this one. Okay. So what is this vertical component right here? Well, its magnitude will be F times sine alpha, as usual. and the horizontal component will be f times cosine alpha. So in this case, what will be the moment around the point A? It's going to be negative f sine alpha times d. At this point, if you have numbers, you're going to just use those numbers. I will demonstrate how to use those two concepts right here through an example involving truss calculations. I hope it was helpful.